Hello everyone, today we are going to present about the Thai NK Plastic. So let's begin with the company overview. The Thai NK Plastic has been established since 1996 by Mrs. Katasasin and Mr. Nitat Mungbunak, which focusing on the plastic packaging manufacturing such as the PET bottle, preform, the cups, the straws, thermoforming products. Right now, I would say that they are operating 3 factories, and the factory 2, the second factory, is the biggest one which we are going to focus about. For the delivery part, Thai NK Plastic deliver products to 20 customers across Thailand, and the customers are both include the factory and industrial client alike. Therefore, we will focus on 20 representative customers that reflect the company main delivery pattern, and there are 4 factories in the north, 5 factories in the northeast, and 12 factories in center of Thailand. And the company operates with 3 trucks. For the labor, Thai NK Plastic operate with 2 shift system both day and night, and they require sufficient amount of employees to maintain continuous line of production. And for the both day and night shift, they require at least 20 up to 25 workers per shift, which sum up to allow 40 to 50 employees per day. And for the wage, the daily wage, the day shift wage will be allowed 372 baht per day, and for the night shift wage will be allowed 558 baht per day.
Okay, after I listen to all of it, I think you have this problem. The company is currently facing operational inefficiencies, especially in the delivery route and labor cost management. For delivery, the company serves customers across multiple regions. There are 3 delivery trucks, but routes are not pre-planned. Instead, they follow a FIFO system, meaning routes are based on order sequence rather than distance. This leads to inefficient travel patterns, resulting in longer distance and higher operational cost. The total delivery distance is 4,567.1 kilometers per week, which is quite high. Separate to the north region is 2,419 kilometers, northeast is 1,420.6 kilometers. Central Bangkok is 727.5 kilometers. This shows that the routes are not optimized and create unnecessary distance and times. Next problems, the company faced an issue with labor costs. Inefficient workforce scheduling can lead to unnecessary expense and poor employee allocation, while enough employees are needed. Each day for continued PET productions, the current system may not be cost efficient. This can result in overstaffing or understaffing, increasing overall operating cost. The company currently has 45 employees, with a total labor cost of approximately 494,848 baht per month. This main issue is not the number of employees but how they are allocated. Therefore, our goal is to optimize both route and workforce scheduling to reduce costs while maintaining operational efficiency.
Our main objectives are split into 2 parts. First, we aim to minimize transportation distance by optimizing delivery route and improving truck utilization for maximum efficiency. Second, we focus on minimizing labor cost by balancing staff level across day and night shift to meet daily demand at the lowest possible cost.
Now moving on to the research journal, as we're going to be using this as our structure to solve your problem. Traveling salesman problem. What we learn here is that we can use Excel distance matrix, decision variable index, and all different index solver and evolutionary solving methods. The outcome is that they can generate an optimized traveling route with the shortest total distance in kilometers. Now the TSP model helped the company plan the shortest delivery route when visiting multiple customer locations. Instead of relying on a FIFO, the company should use the model as a route planning tool before dispatching trucks. If customer locations, order priorities, or truck availability change, the optimal route will also change, so the model must be updated and rerun. The limitation here is that it focuses mostly on the distance minimization and may not fully consider traffic through delivery time windows and truck capacity. The next step is to test the model in real operation and then improving it. Work shift scheduling. The journal applies Excel solver and linear programming to solve a staff scheduling problem. The outcome is that they have the optimum number of workers from 30 employees to 23 employees. A scheduling model helps the company to decide the best number of workers for each shift while keeping labor costs as low as possible. It should be used as a weekly workforce planning tool for a day and night shift. If production demand, wage, or employee availability change, the schedule must also change. So the company needs to update the data regularly. The limitation of this model is that it simplifies real workforce condition because it may not include skill difference, overtime, labor law, or employee preference. The next step is to test the model with actual company data.
After reviewing the company's delivery operations, we identify routing as a key area for improvement. For the North region, the optimized total distance is 1,617 kilometers. For the Northeast region, the optimized total distance is 1,374.6 kilometers. For Central Bangkok, the optimized total distance is 438.3 kilometers. To solve this, we use Excel solver for each region. We set the objective as total distance, selected min, used the route order as the changing variable, added the all different constraint, and applied the evolutionary method. In this mathematical model, the decision variable is the visiting order of locations. The objective function is to minimize the total travel distance, while the constraint ensures that each location is visited only once with no duplication. This allows the model to generate the shortest complete route for each region. From the analysis, the optimized routes provide a more efficient delivery structure. A shorter route means low fuel cost, less unnecessary travel, and better truck utilization. It also helps the company plan deliveries more systematically across each region. When we compare the current system with the optimized model, the improvement is clear. The company already has 3 trucks, but the current routing is still unstructured because deliveries follow FIFO and visiting order often depends on the driver. This causes inefficient travel and higher transportation costs. With our proposed TSP model, the same 3 trucks are used more systematically, and the total distance is reduced from 4,567.1 to 3,429.9 kilometers per week.
About resource and analysis for problem 2. The goal is to minimize total labor cost using integer linear programming. Decision variables represent how many employees start their 6-day shift each day. A binary matrix shows working days and off days. The constraints make sure that the number of employees available each day always meets or exceeds demand, which is 20 for the day shift and 15 for the night shift, and all values must be integers. And the Excel solver is used with integer constraints to get a feasible solution. This approach helps achieve efficient scheduling at the lowest cost. Next, the number of employees working each day is computed using a sum product between decision variables and the work matrix. Then we can calculate total salary by multiplying the number of employees by the wage per shift, and finally extend it to monthly cost based on working days. The objective function combines both day and night shift costs to find the minimum total. Finally, the optimal solution assigns 24 employees to day shift and 18 to night shift. This meets all requirements and reduces total cost from 494,848 baht to 493,272 baht. Overall, it avoids under or overstaffing and provides the most cost-efficient schedule.
From what I heard about the solution that you guys give me, I think that I can use the towering salesman and optimize workforce shift scheduling to an effect. Thank you.